Hello everyone, I am Mudit Saxena, Assistant Professor in the Department of Electronics and Communication Engineering, ABES Engineering College, Ghaziabad. Today we are going to discuss the topic half-wave voltage doubler. So let's have a glimpse on the points which needs to be discussed. So these are the contents of my presentation. First, we will discuss the introduction of voltage multiplier, then its classification. Then we will see the working of half-wave voltage doubler. So let's start with the very basic what exactly the voltage multipliers are. The voltage multiplier is one of the most important application of a PN junction diode. The voltage multiplier gives the output voltage in multiples of input voltage. It means it will give the output voltage 2 times, 3 times or more times greater than the amplitude of the input voltage. So that is a function of voltage multiplier. Now it's come to the classification. The voltage multipliers are broadly classified into two categories, voltage doubler and voltage tripler and quadrupler. If the voltage multiplier gives twice of the peak value of amplitude of input voltage, it is known as voltage doubler. And if the voltage multiplier gives the 3 times of peak value of amplitude of input voltage, it is known as voltage tripler, and it gives the 4 times of the peak value of amplitude of input voltage, it is known as voltage quadrupler. Now the voltage doubler is again classified into two categories, half-wave voltage doubler and full-wave voltage doubler. So in this lecture, we will discuss half-wave voltage doubler. Now this is the circuit diagram of half-wave voltage doubler. Here we can see there are two capacitors C1 and C2, and the circuit comprises of two diodes D1 and D2. We will take the output voltage V0 across capacitor C2. Here, the input voltage is Vi, which is passing through the secondary winding of the step-down transformer. As we all know, electronic deals with the low voltage application. So, this Vi voltage appears across the secondary winding of the step-down transformer. Because this step-down voltage is a AC voltage, therefore it contains both positive half cycle or negative half cycle. So this Vi voltage is the input voltage of this voltage doubler circuitry. Now let's discuss its working. So because this Vi voltage is a step down AC voltage, so it has both positive half cycle as well as negative half cycle. So let's discuss positive half cycle first. So in case 1, which correspond to positive half cycle. So during positive half cycle, this will be plus and this will be minus. Now here we need to find which diode will be forward biased and which diode will be reverse biased. So because the positive terminal of input is connected to the positive terminal of diode D1, therefore diode D1 will be forward biased. And because diode D1 is forward biased, therefore it will behave like short circuit. Now this positive terminal of input is connected to the negative terminal of diode D2. Therefore, diode D2 will be reverse biased. And because it is reverse biased, so it will behave like open circuit. So this diode D2 will behave like open circuit. And this diode D1 will behave like short circuit. So the current will flow from plus to minus. So the direction of current will be like this. So the current will flow in this loop 1. Now let's see the polarity of the capacitor C1 because this is positive. So therefore the first plate of the capacitor C1 will be positively charged and the second plate will be negatively charged. Here we have assumed that the voltage across capacitor C1 is the VC1. So VC1 is the voltage which appears across capacitor C1. So now let's apply KVL in loop 1. So I will take second sign, minus to plus positive Vm. So this is plus Vm. This plus to minus, I have taken minus sign, and the voltage across capacitor C1 is Vc1. And here the loop closes. So that is equal to 0. So thus we have find Vc1 is equal to Vm. It means the capacitor is charged to voltage Vm, or in other words, the voltage across capacitor C1 is Vm. So this corresponds to positive half cycle. Now let's discuss case number 2, which corresponds to negative half cycle. So during negative half cycle, this will be minus and this will be plus. Now again, we need to check which diode will be forward biased and which diode will be reverse biased. So the negative terminal of the input is connected to the positive terminal of diode D1. Therefore, diode D1 will be reverse biased. Hence, it will behave like open circuit. So this diode will behave like open circuit. And because the negative terminal of input is connected to the negative terminal of diode D2, therefore diode D2 will be forward biased. Therefore, it will behave like short circuit. So this diode D2 will behave like short circuit. Now let's see the direction of current. So as we know, the current starts flowing from plus to minus. So the current will flow in this direction. So this is the direction of current flowing. Now let's see what will be the polarity of capacitor C2, because this is negative. So the upper plate of capacitor C2 will be negative charge and the lower plate of capacitor C2 will be positively charged. But here the polarity of capacitor C1 will remain the same, because in case number 1, the first plate of capacitor C1 was positively charged and the second plate was negatively charged. And this is a beauty of a capacitor, that once the capacitor is charged with some polarity, the polarity remains the same. So here also, the polarity of capacitor C1 will remain the same. Now here we need to apply KVL in loop number 2. So let's apply KVL in loop number 2. Positive to the negative. So I will take second sign, so minus Vm. So this is minus Vm. Plus to minus Vc1, because voltage across C1 is Vc1. So this is minus Vc1. And here at capacitor C2, we are moving from minus to plus. So I will take second sign, that is plus. And voltage across C2 is Vc2. So that is Vc2, because we have assumed the voltage across capacitor C2 is Vc2. So this is Vc2 and the loop closes here, that is equal to 0. So here we will put the value of Vc1, which we have already found in case number 1. So the value of Vc1 is equal to Vm as proved earlier. So by putting the value of Vc1 here, we can get Vc2 is equal to twice of Vm. It means the voltage across capacitor C2 will be equal to twice of Vm. So this is how we have calculated the voltage across capacitor C2. Now we will find the output voltage. So here we are going to find V0 across capacitor C2. And we know in parallel voltage remains the same. So this V0 will be equal to voltage across capacitor C2. And we have found out the value of Vc2, that is equal to Vm. So here we will put the value of Vc2. So V0 comes out twice of Vm. It means we can say the output voltage of half-wave voltage doubler is equal to twice of peak value of amplitude of input voltage. Therefore, we can say this circuit behaves like a voltage doubler. Now here the question arises, why is it so called half-wave voltage doubler? Because we are getting twice of Vm during negative half cycle, because here you can see the voltage across capacitor C2, that is VC2 is equal to twice Vm. But during positive half cycle, the value of VC1 was Vm. But we are calculating V0 across capacitor C2, and the value of voltage across capacitor C2 is twice Vm. So we can say we are getting twice of input voltage during negative half cycle, which is the half portion of the complete input cycle. Therefore, we can say this is a half wave voltage doubler. So this is all about the working of half wave voltage doubler. These are the references which I have used in my presentation. Thank you.